A very warm welcome to all of you. Thank you for joining us today for this webinar, which is titled The Role of Geospatial Technologies in Electric Utilities. It's being organized by the Association of Geospatial Industries and is being supported by ESRI India and Maxar Technologies as sponsors and by the India Smart Grid Forum as a knowledge partner. So just to give a very brief background before we call our esteemed lineup of speakers on the floor, we all know and agree that electricity consumption is a very important indicator for national development. 24/7 electricity availability in India will ensure success in many mission mode projects like Smart Cities, Amrut, Make in India, Digital India, and many others. However, there are some critical challenges that this sector faces, like ensuring the last mile connectivity, unequal electricity distribution, lack of timely information on load and demand, consumer level losses, sorry, theft of power, to name a few. Sorry. Geospatial technologies can play a significant role in addressing these challenges for the sector. It helps us to map, manage, and utilize all aspects of the network and helps to increase worker safety, improve decision making, reduce costs, and customize workflows. It also supports proper network planning, figuring out the stress assets, and then to release the stress off the grid in case of overload on transformers. So today, all our speakers will be throwing some light on how geospatial technologies can actually help this sector in facing all these challenges and delivering better outcomes. I'm very pleased to invite the first speaker from Association of Geospatial Industries, Mr. Sai Arul. He is the head of Region SARC at Maxar Technologies, and he's also a member of the governing council of the Association of Geospatial Industries. Just to give you a brief background about Mr. Sai, he has served in the Indian Army for 22 plus years and has thereafter worked in the IT sector in India with organizations like Wipro, HCL, and IBM. He holds a MTech in computer science from IIT Madras, and currently he heads the regional operations at Maxar Technologies. Over to you, Sai. Thank you for confirming and giving us an overview of what geospatial technologies can do for the electric utility sector. I think you're on mute.
Hi.
Yes, we can hear you now.
Can you hear me?
Yeah.
Okay, thank you. And I'd just like to start with a small deck. And thank you, Megha. And on behalf of the Association of Geospatial Industries and my parent organization, Maxar Technologies, I'd like to welcome each one of you to this webinar with the role where we're going to try and address the role of geospatial technologies in the electrical utilities domain. And it's my honor and privilege to represent the AGI, and I welcome each one of you. Just to set the what do we mean when we are speaking of the geospatial industry? It's an amalgamation of all our geographical information systems, our navigation systems, our Earth observation systems, which include satellites, unmanned aerial vehicles, photogrammetry, LiDAR and radar, and their value adds that each one of them bring. Each one of them have a separate set of value adds, and that's something that we expect our subject matter experts would cover in the subsequent chapters or the subsequent sessions. Now, as far as the power sector is concerned, we had, as a nation, we've set pretty high goals for ourselves, like making 24/7 power available to each and every citizen of the country. A very, very challenging target towards the use of renewable energies and their capacities. Reduce our dependence on oil and gas, which we are a major importer of, and the greening part where we have set ourselves goals in terms of emissions and achieving green targets. While There are a whole lot of challenges as listed here, and I'm not a expert in the power sector. However, you are all probably more qualified in that domain, being specialists in that domain. The challenges remain, and there have been multiple initiatives by the government over the years. I remember it started somewhere in the 2002-3 area when the reform started happening in terms of the RAP, DRPs, and we have a whole range of initiatives and programs by the government, starting from One Nation, One Grid to the entire domain, including policies on biofuels, the solar mission. Uh, we are India has taken leadership in the Solar Alliance, and we have achieved a hell of a lot of progress in that domain. Now, while these challenges remain, and YOLAR, the industry is well seized with the challenges, all we are trying to convey in this webinar is the value add that adoption of GIS technologies can bring to your sector. And these are very, very clearly, visible in case they are adopted. And I'm not saying that the geospatial technologies are not currently in use. My impression is that there is scope for a whole lot of additional value adds that we can bring as a sector into this very, very important area of distribution and transmission of power, which is one of the, probably like earlier it used to be roti, kapda or makan. I suppose electricity is become one of those additional, essential commodities which are, which power everything else that one uses today. When we speak of what applications of GIS technologies can bring to the sector, be it right from the inception planning stage, from selection of sites right down to cost estimations, modeling, network planning to optimization, GIS has applications in that domain. Be it operations, right from management of assets, their awareness as to where they are, what shape they are in, workforce management, monitoring, outages, SCADA, everywhere you have applications where GIS can add value to and bring insights into what you're planning to do. And the same applies to the customer support and the audit domain. In fact, people have gone as far as to state that, uh, for a smart transmission or a distribution system, location intelligence forms the very basis of it. Because, and another thing that I'd like to add as a add-on that comes along with the GIS technologies, when we speak of geospatial, we could also include the temporal aspect of it, the time variation of all these aspects, where be it planning, operations, customer support. GIS can also bring the time or the temporal dimension into it by giving you a perspective as to what things were earlier, what they are now, and what probably they could be in the future. Accordingly, some of the very, very evident advantages that adoption of geospatial technologies probably would bring into this domain, be it effective planning of the transmission and distribution requirements, efficient project management, decision making, management of assets and operations themselves, customer services, transparency.
Mr. Sai, can I
Yes.
request you to switch off your video feed because the PPT is not very clear.
Okay, just a sec. got deactivated, Megha.
Okay, then I think we can continue with the presentation.
Okay, actually, this was the last slide. In
Yeah,
fact,
we will make the presentation available for people who are interested in it.
okay, I wish you'd stopped me earlier because, any case, I'll continue from where I was. So all that I was trying to say is that the geospatial adoption of geospatial technologies brings about significant value add to your domain, be it transmission or distribution, and I would extend it to all other utilities other than the power sector. There are significant advantages of adopting geospatial technologies, and that is what some of the aspects and value adds would be covered in subsequent sessions by our experts in the domain who have sessions adopted. And with that, I'd like to hand it over back to Megha to introduce the next speaker. And thank you so much for being here. And it's a pleasure interacting with each one of you. Let's keep the session interactive, and let's both gain from each other's expertise in our respective domains. Thank you so much for being here.
Thank you, Sai, for giving a very good overview. And our apologies for the presentation, which was not very visible. We will make sure that whoever's interested can get a copy of the presentation. So I would now like to invite our moderator for the day, which is Mr. G.V. Sriramam. He's the CEO of Neo Geo Info Technologies, and he's the Secretary General of AGI. Sri has over 25 years. Hi, Sri. He has over 25 years of experience in geospatial industry. His company NeoGeo Info provides geographic insights to a large government and corporate organizations that need geospatial intelligence to mitigate risk, plan for growth, better manage resources, and advance scientific understanding. Sri holds a civil engineering degree from BITS Pilani, and as I said, he's also the Secretary General for AGI. So Sri will be moderating all the speaker presentations. With that, we have the first presentation for this webinar by Mr. Reji Kumar Pillai. He is the president of our knowledge partner organization, India Smart Grid Forum. Reggie has been the president of ISGF since 2011, since its inception, and he is also the chairman of Global Smart Grid Federation since November 2016. He is an internationally renowned expert with nearly 4 decades of experience in the electricity sector and is spearheading a mission to leverage technology to transform the electric grid in India and provide clean and reliable electricity to every citizen, 24/7 at affordable cost. His current areas of research and work include grid integrated vehicles, district cooling, electric cooking, smart grids as anchor infrastructure for smart cities, grid interactive buildings and campuses, AI, robotics, and blockchain applications for utilities. He has studied engineering, finance, management, and law, and he has worked with NTPC and IBM and has been a senior consultant with the ADB, World Bank, and USAID. So with this, I welcome you, Reggie, to give your presentation.
Good afternoon, good evening, good morning to people attending this event from different geographies. First of all, thank you very much for inviting ISGF to be part of this event on this digital platform. In the past also, I have had the privilege to be addressing this forum physically. Now, as we go through this very difficult phase, we are able to do these programs and also interact, provide all kinds of services, including medical services, because people are getting 24/7 electricity. So I often tell the electricity workers around the world who are working 24/7 to give reliable electricity all across the world. That is not been credited properly, not been acknowledged properly, the measures which electric utilities have taken. Otherwise, all these interactions all these services, including medical facilities, would have been extremely difficult without 24/7 electricity supply. So kudos to the electricity workers around the world in doing this selfless service. The GIS technologies, electric utilities started embracing the GIS technologies towards the end of last century, or almost 2 decades ago. It came to India also. Started with the private utilities in Delhi and Bombay, particularly the ones after privatization in Delhi. That time, everywhere it was just a digital map. You had a map where you can index your assets and your customers. And the initial struggle was to integrate that with SCADA and distribution management systems. And it was included as a major, although outside of Delhi, very little GIS was done by distribution utilities, electricity distribution utilities in India. Many of the forward-looking agencies involved in the RAPDRP program design in 2007-2008 worked with the Ministry of Power to include GIS as a major tool in the RAPDRP program that covered 1,410 towns across India, and which has been implemented over the years with varying degrees of success in different places. So many states, many towns, we hear complaints that it has not been updated. But at least you have a map now, although it is 5-year-old or maybe 1-year-old. Well, it was nothing of that sort was available in the past. We still remember the interactions I had with the Tata Power and BSES, which took over electricity distribution in Delhi. Those days, what is there on the paper, the asset, it was not there on the ground when they go look at it. And it is a very limited area, Delhi itself. What is on the paper was not there on the ground. They had to physically do everything to have a digital map of their assets and the customers with a great difficulty in those years. The same thing we have been able to replicate in or emulate in 1,400 plus towns is a great step forward. We used to demand that the work process need to change. Once you do one feeder, if you do the GIS, you put your customers, you put your assets on the digital map. The change, any change which is there on adding a new customer or making any changes on the network, first that should be done. Once it is approved, it should be done on the digital map before it is actually done on the ground. That's the way the business process needs to be realigned. Otherwise, the map will always be behind the actual asset on the ground. These two things should match on a daily basis. So there has been other limitations of the GIS which we adopted in RAPDRP. You should remember that this was something which was planned in 2007-2008. The system requirement specifications for RAPDRP was prepared in 2007, which was approved by Government of India in 2008 and implemented over the next 5 to 7 years. And this has been extended to several more towns in the other program called IPDS. So electricity utilities in most of the urban India today have a digital map. So I again take the caveat of it may not be up to date in some places or in most places, but still, whether it is few months or a year old, we have a digital map, which is a very important tool for planning the electricity network as well as other services in the city. In 2014, when the 100 Smart City program was launched by Government of India, we had released a white paper. We said, advocated that the digital assets available with the electricity utilities can be leveraged for building smarter cities at marginal cost. So one of the main tool which we talked about is the GIS map, which is available, the digital map, which is available with the electricity distribution companies that can be shared with the other smart city development agencies through appropriate agreements. And all the customers, all the roads, all the buildings in the city are captured in this map, which is a very, very valuable tool for those who are planning, laying new road, new water pipelines, gas distribution pipelines, security cameras, all this thing can be mapped on the same map. And we also talked about having combined billing and collection systems, about the sharing the last mile communication bandwidth, the call centers. The electricity distribution companies have call centers today, which is on a 4-digit number, which we implemented across India now. So that can be again extended at marginal cost to other city services. So GIS being a very, very important tool, which we have been doing for all these purposes. But of late, if you look at from a simple digital map, it has become a very essential tool today. And as I said, initial struggle was to integrate with SCADA and DMS. But today we are looking at, or we are already GIS map of the electric utilities are integrated with the complete ERP and systems, the billing and CRM systems, network planning, demand forecasting, vegetation management. All these systems are integrated with the GIS maps. You look at demand forecast. We earlier never bothered about, we looked at the total demand for a distribution company in a state. But today we are more worried about, in Delhi, if I have 2000 megawatt in BSES, I need it for tomorrow. I need to know whether it can give me 100 megawatt in Chanakyapuri. Do I have my transformer constraint? Do I have any other constraint here? So, and maybe day after tomorrow, I may not have 100 megawatt requirement in Chanakyapuri at a particular time. So I need to capture my demand and my availability, network constraints in real time on a digital map. It has become a very, very important new tool. Earlier, whenever we had a problem, we could do a load shedding. Today, we cannot do that. We have to get into advanced demand side management applications, where again I need to know the exact location, and that need to be correlated with several other parameters. So emission monitoring, forest fire, so many other things which are happening, all we need to capture on the digital map and monitor it. The another very important thing which is emerging of late, past couple of years, is the satellite data integrated with the GIS, the local maps. So satellite data is being increasingly used for terrestrial applications of late. Initiatives from European Space Agency, NASA, and other agency technology companies and space agencies sharing the satellite images for terrestrial applications. And today we use the spatial maps, spatial images, space images for asset monitoring, for energy mapping, and a host of other applications. So predictive maintenance, vegetation management, as I said, flood and storm impact on my infrastructure, ground deformation, all these things. End of the day, even if I get it from a satellite image, I need to know exactly where is it on my asset, which are my poles or my towers or my substations which are impacted by any of these incidents, or which I am seeing from the satellite images. So integration of this. So the confluence of several technologies today, including AI and artificial intelligence and machine learning, all integrated with the geographical information system, is a very, very valuable tool for planning and managing the electric utilities. Same with the pipelines, water pipelines, gas and oil pipelines, with city gas distribution systems, all other important infrastructure and its maintenance. So I'll be very happy to take any questions, if any. I'll stay for another 30 minutes of the program, and 4 o'clock I need to leave. Thank you very much, and over to the moderator.
Good afternoon, and Mr. Pillai, I'm very thankful that you have given a complete overview of about how the Indian geospatial industry has been contributing to the electric utility as a whole, starting from RAP DRP project and integrating with SCADA and DMS. Especially, I request all the participants, if they have any questions, they can type into the Q&A session, so that I will be able to ask the speakers all these questions that are there from you. I would like to just add to what Mr. Reji Pilla has commented on. One of the things that he has highlighted upon is updating and keeping the maps current, which is, I think, a very, very important thing that is required for having good analytical tools for electrical utility. But sir, I want to ask you a couple of questions. What are the initiatives that are taken by NSGM, that is the National Smart Grid Mission? Because when we talk about smart grid, obviously NSGM is a nodal agency which will be initiating the projects and also taking up certain projects, grant the funds also. So what are the initiatives that NSGM has taken? And secondly, how we are able to reduce the losses further in distribution networks, because that is where the entire pain is. The transmission networks are not the main issue, but the distribution network. So if you could throw some light on these two questions, I'll be very happy.
Well, I am not the right person to talk about NSGM initiatives. I represent India Smart Grid Forum, and National Smart Grid Mission is a Ministry of Power initiative, which is their secretariat in the Power Grid Corporation of India. But we work very closely. So one of the main difference between the 14 pilot projects which were allocated as part of RIPDRP, the smart grid pilot projects in 2013, is that 50% grant was given from Government of India to those projects, and all of them were very small projects, and there was a very small money to be invested by the respective distribution companies at that point in time. In the NSGM framework, unfortunately, the grant was reduced to 30%. And NSGM was mandated to take up very large projects, which are 200 crore, 500 crore projects. And distribution companies, when NSGM launched these initiatives in 2016-17, most of the discoms were still struggling to cope up with a variety of programs. One, finalizing or completing RIPDRP in many places, work was still pending. And in addition to that, DDUJY, the rural electrification program, Saubhagya, all kind of power for all kind of programs which are going on, both central and state level programs, and they had real capacity issue, more than money capacity issue. And some of the projects which was proposed did not take place as envisaged. So now some projects are going forward, and one of the main constraints, as I said, is that 30%, 70%. Utilities need to invest 70%. And another new initiative which Ministry is launching is smart metering mandatory for all the customers in the country, and which is going to be taken up on a services model. Again, in 2017, when smart metering was not going up well, under the new tariff policy, government mandated that by 2018 December, all customers with a minimum monthly consumption of 500 units and above should be brought under smart metering, and all customers with 200 units and above per month should be brought under smart metering by December 2019. And nothing much was happening during 2017. We again published a white paper which advocated that it will be very difficult for discoms to, particularly the government-owned discoms, to implement smart metering and maintain that, because of the various technologies involved in that. The metro, other than the metering technology, you need communication technology, which keep changing, and IT and system integration, which is beyond their capability to maintain all those systems. So we said that it should be done on a complete outsourcing business model, metering as a service, engage an agency who will implement smart metering and maintain it for a monthly fee. So we have done some modeling studies. We said that the meter prices, if go into millions, can come to something below 2,500 rupees per meter. Those days, smart meter price were 7,000 rupees in 2017. And also we said that somewhere close to $1, those days dollar was also about 70-75 rupees. So we said a dollar a meter per month for 10 years is some number which is perhaps possible. Even if it is 100 rupees, it's still okay. So that is now catching up. So most of this 250 million smart meters will be implemented on that. You talked about the AT&C losses, which we call aggregate transmission and commercial losses in the distribution system, 33 kV and below system. It used to be somewhere when we started with the APDRP in 2002-2003, it was 35% nationally, with many states, large states reporting more than 40%. Through a variety of focus programs, of course, APDRP, RAPDRP, IPDS, all these programs, Uday, we've been able to bring the nationally these losses from 36% to something around 18% today. 50% reduction in losses nationally is a great achievement, and all the money we spend under all these national programs, it's already the return on investment has already come. And although we still have some states, some regions reporting more than 25% or 30% of the percentage losses, we sure will be able to take appropriate action to bring this down. So there are many places which were about 25% has now come below 10%. So now the areas are very focused, and we will be able to bring it down in the next 5 to 7. By end of this decade, most of India will be somewhere around 10 to 12%, and all the good areas will be well below 10%.
So hopefully every DISCOM will be able to do an energy audit, and they'll be able to bill most of the power that they're distributing. So that would be a good news for the DISCOMs as well. I would just look at any question.
All feeders are already metered, and feeder-wise energy accounting we are able to do, but it's not able to match with the time-stamped information of the individual customer meter data, because we don't have smart metering. When we have smart metering, the feeder has a meter. If the feeder meter says in last 24 hours I sent in 1,000 units of electricity, I should be able to see my 500 customers down who has consumed how much. That information I don't get it on a daily basis or on an hourly basis. I get it on a monthly or a bi-monthly basis. So we'll be able to do all that with smart metering coming forward. Yes, you are asking some other.
In fact, there is a question from Megha from Megha from AGI. This says you are also the chairman of Global Smart Grid Federation. So can you share some good practices that that were practiced in other developed countries, which could be probably used here as well in India?
Okay, sure. How much time we have?
We have another 5-6 minutes, sir. No problem.
Okay, you can. Okay. So, Global Smart Grid Federation was launched along with ISGAN, International Smart Grid Action Network, an intergovernmental agency. 27 countries are members of that, and both were set up in 2010, and by Department of Energy and IEA were the main promoters of this. So most of the people who joined that time, both ISGAN and GSGF, were developed countries: US, Ireland, UK, France, Japan, South Korea. All these countries were. And at that point, some point in time, GSGF had 18-19 members. Later, many places, the smart grid associations which are set up in some of the bigger countries also, they couldn't survive, because many of these associations were membership oriented, and membership fee was the only revenue for them. So in many countries, they became they went dead. They were not existing. So we have come down to below 10. Then they wanted. I handed over the position of the chairman to me in 2016 end, and we changed the chapter. And here again, we have members from associations from different countries. One of the first thing I did was to change the chapter, and in 2018, we, in a country where there is no smart grid association, we invited utilities. We have utilities from South Africa, from Thailand, from Malaysia, and now from Italy and a couple of other places. They are in the process of joining. So we are taking utilities as members. We are also taking think tanks as members. So to expand the membership base. And also this year, early this year, we changed the name from GSGF to GSEF, Global Smart Energy Federation. As I said, many of these associations which are our members in Global Smart Energy Federation, they are from developed countries. Many of the digital solutions are already implemented a decade ago. Like in US and most of the European countries, smart metering has been done. All of them have state-of-the-art digital technologies, including digital maps, and artificial intelligence and other solutions are being deployed there successfully. So the idea of this association is to experience sharing. So everybody talk about their success stories, but what did not succeed, what went wrong, what policy, what regulation, what technology deployment did not succeed is an information which now typically not shared on the public platforms, or it is not even published as a white paper. But through this closed door networking session, we don't need to reinvent the wheel. Something which did not work in USA, we did not try in India, or something which did not work in India need not be tried in Malaysia. So this kind of experience sharing we do, and we have a very good experience of sharing this information. Our experts participate in national events in each of these countries, and we used to be quite vibrant in our activities. Thank you.
Thank you very much, sir. And it was a wonderful presentation. It was very enlightening for us, and hopefully more and more best global practices will be practiced here as well, and we will be able to achieve a good supply of power to all the people, industry as well as residents across India very soon. Thank you very much.
Thank you very much.
Thank you, Mr. Reddy.
Thank you. Good luck.
So now I invite our next speaker, Mr. R. Lakshmanan, IAS. He is the CEO of Rural Electrification Corporation Power Distribution Company Limited. He is an IAS officer of 2004 batch from Bihar cadre. He has done a BCom from Annamalai University. He's also a fellow of the Indian Institute of Chartered Accountants. He holds the position of the Executive Director of REC Limited since 2019 and is looking after stressed asset management, IT, admin, estate coordination and monitoring of government programs like DDU-GJY, Saubhagya, Uday and PFA. Prior to joining REC Limited, he has served for 14 years in the government of Bihar and held various important positions, including the Managing Director of Discom, Transco and Genco, District Magistrate of Darbhanga and Saharsa districts, ACEO, Rural Road Development Agency, and Additional Chief Electoral Officer. I welcome Mr. Lakshmanan. So may I request you to, if possible, switch on your turn on your video and audio, please. Yeah, we can see you, sir. So I think you're on mute. We can't hear you. No, we can't hear you, sir.
We can't hear you, sir.
There is an audio button right next to the video one.
Is it okay now?
Yes, now it's okay.
Right. Okay. Thank you. So, thank you. Thanks for that introduction. I think today we are discussing about the geospatial technology and its applicability in the electrical power systems. In fact, this is still in very nascent stages in terms of its use as a technology in the Indian power sector. But then its applicability is definitely immense and huge. The kind of benefits and use cases for using this technology is definitely there. Of course, at the transmission level, at the high voltage level, maybe by power grid, And by certain transmission companies, definitely like they are able to utilize geospatial technology for mapping their assets into their operational softwares and derive value out of that. On the other side, in terms of what are the possible broader level use cases which is possible, is in terms of once you have the entire power distribution network or the transmission network, once you map all these assets on a GIS platform, then you have a complete visualization of your network. Then if you extend it further, then you get the consumers on board. Then you have an entire utility map on the platform. With that, then one is able to identify what is the nature of gaps in the network that is there, and how does one improve upon or plan for the capex requirement in the most optimal manner. And the other part is like once all the consumers in the network are mapped, then they are tagged to the relevant distribution transformer or the feeder. Then that forms the foundation of the entire process of accounting of energy and determining your losses. And then like you are able to do targeted interventions for loss reduction, which is one of the key challenges that the entire Indian power sector today faces, because of which the overall financial viability is under stress for the entire sector. Then moving on, like one could also look at the operation and maintenance benefits which is likely to come out of such kind of exercise. As in, like whenever there is a outage, once all your consumers are mapped, then it is very easy to figure out where exactly are the consumers located, and then your outage management system can actually like get triggered, and it can work on the basis of this. And having said all this, like there has been like certain efforts in this direction, wherein the REP-DRP program, which was basically like targeting the urban area sector, in which this was attempted, and across the India, major cities were taken up for trying this out, and which has seen reasonable success in terms of getting the assets mapped onto the GIS platform, and then integrating it with the system automation, SCADA systems, and the distribution management system, which to a large extent helps the distribution companies understand and manage their network in a better way, and attend to their operation and maintenance, and service the consumers in a better manner. Then moving on, like in terms of the rural area programs, the efforts have been made under the Deen Dayal Upadhyay Gram Jyoti Yojana and Saubhagya, wherein like the first program envisaged electrifying all the unelectrified villages. So all the unelectrified villages were surveyed and mapped on the GIS platform, and its electrification was also like put up transparently for the people at large to look at. And this was done using the Garv mobile app and platform. This essentially like brought in more transparency and put a lot of pressure on the states and distribution companies to actually like work on and achieving the targets within the time frame. And the second part was like when the company embarked upon the journey of universal electrification, similar efforts were made through the Saubhagya scheme. And many of the DISCOMs responded, and in fact, they captured each and every household which was unelectrified through a mobile app, and which had a GPS coordinate which was captured, and then it was plotted on the map as well. So that also like gave a spatial representation of which are the areas where people are left behind. And interestingly, like one could then keep tracking out of these unelectrified households who are all electrified. Then gradually, like you could see how the people are getting electrified, and how the pattern is emerging, and where it is lagging behind. And one could specifically target those areas for interventions and improvement in performance. And as the program was getting completed, then one could also identify where the electrical network has reached, and maybe a group of consumers have taken connection, and there are other dots representing these unconnected households, which are very nearby the existing network, but they have not taken connections, which essentially like would indicate that probably like they are resorting to theft and taking electricity illegally. So that also like triggers the action point wherein like people can reach out to them and understand what are their concerns, why are they not taking a connection, and they could also be like onboarded onto the grid. So these are broadly like across urban and rural area programs. These are some efforts which have been made to bring this technology into use. And moving on, whatever assets have been created under the government programs under the rural segment, especially the Deen Dayal Upadhyaya Gram Jyoti Yojana. Now Ministry of Power and REC, we have taken steps to create a platform, GIS platform, on which we have tried with 5 states to get sample data from 5 districts and then put it onto the web platform, the GIS platform, so that we are able to map the assets which have been created out of central government funding, and also to add on the assets which are already existing or it is created out of the DISCOM or the state's own funds, so that like we have a comprehensive network of the entire power assets. So it's a new initiative. In the last 6 months, it has been initiated, and it is being done in coordination with NIC. So NIC at the national level has already developed geospatial platform for the country as a whole, in which it has different layers in which various kind of assets, infrastructures, and other attributes are already mapped. So what we are trying to essentially do is like put a electrical or a electrical power system layer on top of this network, on top of this map, so that like it adds more utility, and we can also like derive benefits out of the existing layers which are already there in that system. However, having said this, as utilities embark on this journey, there are certain things like challenges which one faces, especially in terms of the comfort with the entire geospatial software network, how to use it, the availability of skills, and the adequately equipped human resource is a challenge. So that is one area where people have to work on if we have to really like take this technology forward. And second, for the first time to capture data is again a challenge, where physically like surveying all the assets is one way of getting all the assets onto the map for the first time. Or probably like LIDAR technology or other things could be thought of, like and see how the attributes can be then added to the map which is generated out of that technology. And the next important thing which is very critical is like to keep the map or the geospatial mapping which is carried out up to date, because what has been seen is like in programs like RAPDRP, where the one-time activity of capturing the existing assets is done, but going forward, the utilities, if they don't keep it up to date, because every day there is a change in the electrical network, a new connection might be given, a new distribution transformer is put up, new lines are created. So if that is not updated, then the entire data becomes kind of outdated, and then the extent of utility that one can derive out of this data becomes significantly diminished. So what essentially needs to be done is like once you do a geospatial mapping, it is essential that that geospatial information and data is integrated into the operational processes of the utility. For example, if it is integrated to the operational software, many utilities have ERPs. So if the geospatial software and data is integrated into the ERP, then for any new asset creation or for any maintenance to happen or for a new connection to happen, then it becomes process driven. Unless the geospatial updation happens, the ERP should not permit any asset addition or any O&M to take place or any new connection to take place. If that kind of process integration and checks and controls are put in place, then the geospatial data remains current and it is real time and it is up to date. Then one is able to really like derive value out of this entire effort and time and value which is put into this. This has been achieved by some utilities which are really like who have understood the value of this technology. For example, the Tata Power Delhi, the Reliance BSES in Delhi, CSC Calcutta, and Bangalore Electric Supply Company, BESCOM, and Maharashtra and Gujarat DISCOMs. So they are, understanding the value of this technology and how it can bring in improved efficiencies and savings in cost. So they are able to keep this software and data up to date and integrate it into their routine processes. Then they are able to derive much more significant value out of this entire exercise and effort. So this is, I think, the most critical part, rather than like taking and carrying out a one-time activity, to integrate this technology into their core operational processes, so that like it stays together and moves forward. Then one can really like derive value out of this entire technology. So I think with that, I would like to complete my part of the remarks. And if there are any questions or interaction, then we can take it forward.
Yeah, Mr. Lakshmanan, I'm Sriramam here, General Secretary of AGI, and I would like to thank you for a very comprehensive, speech about what are all the various things the governments are doing on rural as well as urban sites, and also pointing out some of the issues, key issues that need to be addressed for resolving for better usage of geospatial technologies in the electricity domain. I would like to ask, before I just check for any questions from the audiences, I would like to just touch upon a couple of things that you have said. One is a platform that you are actually creating with NIC. NIC has the Bharat Maps platform, which they have already developed, and you are planning to create a layer on top of that for electrical utilities and all the consumers and things like that. So, what is the role of REC PDCL in this? And also, are you looking at creation of an electrical layer for the entire country on top of the Bharat Maps? That's one point I would like you to please elaborate a little bit on. And the second is, you touched upon a very, very interesting and important topic. Whenever we talk about this geospatial technologies, we talk about improvement of skill sets in the organizations which are implementing it. See, here we are specifically talking about the DISCOMs. Is there any other projects that are coming up? Because we see when you talk about updation of the maps once they are created, there is a second part of the RAPDRP project that is happening for updating the delta changes across all the DISCOMs. Wherever this project was implemented, they are coming up with delta changes projects. So is there anything that you are coming up with skill set? Because that is very, very crucial. You touched upon that point, and we would like you to please elaborate on these two topics.
On the first point, Bharat Maps NIC has, and essentially like what we are trying to do is like the primary intent is to capture the assets which are, we are creating an enabling environment where the electrical assets layer can be captured. So we are putting in place all the electrical components and defining the attributes that needs to be captured, so that web-based interface is given to the DISCOMs to port their data into this national level layer, and also coming up with a mobile app with which they can add on to new assets which are being created. So these are two enabling things which we are doing. And the primary objective is to start with capturing the electrical assets which are created out of the Government of India funded projects. But essentially, we are in discussion with the DISCOMs to port their data also. Like unless you have the entire electrical network data onto the platform, it might not be really like useful, because having partial data, it might satisfy our purpose of asset identification. Whatever we have funded, we would like to know where it is and how it is, and how it is spatially spread out and all that, and also to act as a enabler for the upcoming government programs where planning exercise is taken up. Then where are the assets that are already created and where they exist, and where is the gap. But to have a comprehensive planning, it is important that the entire utility assets are mapped. So we are beginning with Government of India funded assets, but then we are actively trying to discuss with the DISCOMs and get their complete network ported onto this layer. And state to state, the situation varies. Some states are advanced and they have a significant amount of data already mapped by their own efforts. So, probably like that's a good way to start, and then like gradually build upon this initiative. And second part, in terms of skill sets and skilled manpower for this particular technology and segment, that's a point of concern. In fact, like as on date, like there is no specific initiative for coming up with this skill upgradation requirements from the Ministry of Power's perspective.
Mr. Lakshmanan, I just want to add here that along with the Survey of India, AGI is working on creation of set of skill importing courses, and we are actually trying to bring in trainings for various user organizations, not only the students at various levels, but also to the user organizations. Will you be interested in becoming a part of that when this is finalized from Survey of India and AGA side?
I think we can definitely engage, open a conversation on this and try and understand and maybe coordinate with the state utilities and see how far they would be keen on taking this up. And in fact, incidentally, REC has a Power Training Institute, All India Power Training Institute, which is situated in Hyderabad, where we train the DISCOM officials of various levels, and transcos also, like on various key segments and areas. So definitely, like we can look at having a kind of a dialogue with our training institute with whatever modules you are suggesting, and see that wherever there is a need for the DISCOMs to upgrade their skilling, then definitely like one can look at this option. This is actually could be a good area to work on.
Sure. Thank you very much, Mr. Lakshmanan, and we will definitely be in touch with you from AGA side so that we can see how we can take this opportunity forward. And I see no further questions from the audiences, so I would close this particular session here, and I would request Megha to request the next speaker, please.
Thanks. There's just one question from Prashant Hatwar. He's asking what could be approximate percentage of losses in distribution system before it reaches the consumer end, and how can it be monitored or minimized? Would you like to throw some light on that?
Yeah. If you talk about the technical and commercial losses in the distribution system, the all India average as on date is roughly around 21-22%. So that is the losses that one is facing at the national level on a average basis. But utility to utility, it could or state to state, it could be different. Some states operate at 15% or 12% losses, whereas some states which are operating at 28, 30, 32% losses. So it's a quite a wide spectrum. So there is a lot of efforts that are needed to reduce these losses. But the first step is to actually like account for this energy and plot this energy where the losses are. So that is where the system metering becomes very critical. Basically, the distribution transformers and feeder metering is done properly, and then the consumers are mapped onto these distribution transformers and feeders. So this consumer indexing becomes the next step. So once a utility is able to carry out these basic two functions properly, then the identification of losses becomes exact, and then one is able to respond with various initiatives or interventions to bring down these losses.
Great. Thank you so much for your contribution, sir. Thank you for joining us today.
Thank you. Thank you. Thanks for having me.
So we will move on to the next speaker for the day. We have Mr. Dhruba Banerjee, Head of Group GIS from Tata Power DDL. Dhruba has been working with Tata Power Delhi Distribution Limited as Head of Group GIS. He's responsible for the geospatial technology vertical. He has over 18 years of experience spanning complete software development, lifecycle, and IT consultancy for the enterprise information systems, including GIS. content management solutions, geospatial analytics, etc. Dhruba has designed and implemented solutions for integration of GIS with modules related to connection management, energy auditing, operations technology, asset management, etc. He has exposure to cross-cultural work environment with various on-site assignments in India and abroad. Today, the title of his presentation is GIS at Tata Power DDL, Role, Script, and Sequel.
Very good afternoon, my friends. And thank you, Mr. Reggie, for highlighting the fact that from where we have started, the initial challenges that entities like Tata Power DDL and BSES has been facing. And also thanks to Mr. Lakshmanan for acknowledging the good work that some of these discoms, including ours, are able to do. And I'm quite confident that all the other discoms shall follow. So hi to all of you. So I'll switch off the video for the moment now and go to the presentation, and then I'll come back. So this is the overall footprint that we have got as Tata Power. So we started in Mumbai. It all started in 1915, and then came Tata Power Delhi in 2002, which was followed by Tata Power Ajmer, and then now we have got into the licensing for Odisha as well. I'll be focusing on Tata Power DDL in this context. So when we started, it was 02, and now it is 20. And you can see the figures that the AT&C losses have drastically reduced from 53.1 to 7.8% now. We are in single digit. The system reliability has also increased manifold. The failure rates have reduced. So these have been really the benchmarks that we have set for ourselves. And if you look at the right hand side, we are a joint venture between Tata Power and the Delhi government. And we've got about 1.8 million consumer base. And peak load of 2069 we had reached. And then it's about 510 square kilometer to the north and northwest region of the NCR of Delhi. So the foundations for a smarter grid, if you look, so we are in the distribution business. So you've got the 6333 kV network, followed by the 11 kV and then the LV network. The associated terminology will be, one is the subtransmission, which is complemented at the operational side by SCADA. Then you have got the 11 kV, which is complemented with DMS at the operation side. And then you have got the LT and the outage management functions. Together now, it has evolved into ADMS, or Advanced Distribution Management System. Now, this is what you typically require to work in a smarter manner, to have a smarter grid. And we were very clear that to have this, you need to put into place some foundational technologies. And these foundational technologies, one was GIS, the other was the communication network. Based on that, if you see, we started way back in 2007. That's when the GIS got the inception for Tata Power. In 2010, we integrated that with OMS. I'm missing out. I'm not mentioning the small integrations that we did in between that we'll be covering as a landscape in the later slides. 2016, we rolled into, we integrated with Advanced Distribution Management System. And now 1920, we are looking beyond for distribution and distributed energy resources, geoanalytics. We have set up our own continuously operating reference station now for accuracy in the positional accuracy of our asset location, and then mobility. So I'll be touching upon this, and it is our pleasure to share that at the time of inception, we got recognized with the Edison Award. 2016, we got the Geospatial Excellence Award, and in 2019, we have been complied with CMMI Level 5. So what are the constituents of Tata Power DDL GIS? It's the EHV network, the grid internals, the HT, LT, and all the consumers and poles. And the grid internals are a schematic representation. Rest all are actually georeferenced. So what is a typical GIS implementation in a utility? Like Mr. Lakshmanan was mentioning. So yeah, this is how it starts. It's the groundwork. You acquire data from your legacy systems. Then you evaluate the data. then reports are prepared, you prepare a base map, database design, projection. So all thing typical to GIS is done as part of the initiation stage. But after that, now there are challenges in that also, that by the time the project is rolled out, there have been changes in the ground reality. So that is one part of project management that is to be ensured. And there are ways to do it, and I'll be covering those as well. But then comes the sustenance part. And this is where actually a GIS either lives or it dies out. So I'll be trying my best to cover a few of the learnings that we have had to ensure a GIS that is agile and live. This is overall the landscape that any utility aspires to have, and so do we have. So at the center is the geographic information system, but then to ensure that any new work that you do gets updated in the system, you have to have a strong integration with your asset management and work order management, which is typically your ERP. That's the bottom center that I'm talking about. Based on that, so unless until, so we introduced a process interlock that does not allow capitalization to be done unless and until the bill of quantities has been tallied and done okay by the GIS group. Digitization is done accordingly. We've got a dedicated team. At the time of new connection, the technical feasibility of a new connection is gauged using the data generated from GIS. So you've got the transformer to a consumer connectivity hierarchy being generated from GIS. And based on that, the technical feasibility at the time of handing out a new connection is done. Similarly, energy auditing, the same principle is applied for energy auditing. And yes, like Mr. Pillai mentioned in the morning, at the start of the session, that when we'll be having smart meters, the time slicing of these reports will become much more accurate. We have done our bit in ensuring that even without using smart meter, how much best we can achieve by integrating energy auditing, not only with GIS, but also with the operational side ADMS. So that is something that we are exploring to improve continuously. The network planning part, I'll be having 2-3 slides on that having a GIS based network planning has got its own set of huge merits. And then once this data is updated in the system, that is utilized for operations management. And typically this is the litmus test of any GIS implementation, because now you've got a live there are people working out there referring your data all the time, and if that goes wrong, then it's complete chaos on field. So this typically becomes the litmus test, and one of the reasons and motivations that once your GIS expands to a operations management function, it sort of gets even more attention than ever before, because now everyone's stake is into the system. And that is one of the things that our learning has been, to get the stakeholders on board. And then of course you've got, so the ADMS function typically talks about fault management, planned interruption, and prediction. So if anything goes wrong, where could the faulty device may be? So these predictions are handled using ADMS system. To give you a glimpse of how things are, so we key in a consumer's phone number, the consumer gets located. So this is our GIS. It's a screenshot of that. And one can trace the consumer's upstream network, downstream. So this one has traced to the transformer. Now this hierarchy is maintained for 1.8 million consumers of ours and every asset on field. And with this topology available, it becomes a baseline for operations management. Fault prediction, where a fault might be. So if there are 3 customers calling and the system is able to analyze that all these 3 customers are on the same pole, so then the system predicts that there must be something wrong with the distribution box. But then a 4th customer calls and hey, he's not on the same pole, but look what, he's on the same feeder, because the feeder route is also updated in the system. Like Mr. Lakshmanan was mentioning, that with those data available, the system can predict a higher level fault must have occurred. And this way, and since everything is georeferenced, my crew is then able to reach to a predicted device at fault using the coordinates that are available updated in the GIS system. So that is why that's the story, that how did we ensure our time for restoration has reduced so well, is because of the fact that there were technology interventions that helped us in achieving so. Now I'm talking about network planning. So this is typically what we have been doing with a non-georeference network planning. Our friends in the network engineering group would be digitizing their own network. It will be mostly in the form of single line diagrams and doing the analysis based on attribute value. So yeah, so this is what. So planning is done on single line diagrams with no correlation to the geography. The feeder length is maintained as a parameter. It's not the actual route. There's duplicate efforts, of course, because you're redoing things and you have to assess it from field all the time. And there are also tee-offs that are not well identified when you do a digitization like that. The moment you put GIS and define an interface between the GIS and the network planning tool, this is what you get. One, you get a standardized nomenclature. So every feeder is now known with the same name across the organization. So we call, and that is the aspiration that every utility has, to have the GIS as the single source of truth. No, Eka Brahma Ditya Nasti kind of a situation wherein the GIS acts as that reference point, that whenever you're talking about network, or whenever you're talking about location, the only system is GIS. And that data can be leveraged by your planning, by your operations, by your commercial functions as well, like we've been doing. Another example was how we, at the time of smart meter deployment, so smart meter needs a network infra. So as I mentioned in the beginning, that the network, the foundations for a smarter grid consists of your GIS. Of course, ERP plays a major role in many other systems and on-field deliberations and things has to be done on field. But at the same time, the network topology or your network mesh that supports your communication of the on-field devices with the backend systems. So at the time of doing so, we found a very novel way of how GIS can be leveraged. So the buffer that you see, the blue areas, are actually our own optical fiber cables, and our estimation that till how much length we can utilize the existing infra. And then where do we need to create a corridor by putting repeaters. So the GIS data was also utilized for planning our smart meter deployment. Now the typical plan, build and operate. So in the ERP, you typically start with creating a scheme, because every work that we do is narrows down and becomes a scheme first. The scheme is created in the ERP, for which an overall plan is prepared in the network planning tool, like I displayed before, that uses GIS data. Then after some on-site assessment, these schemes are broken down into sub-WBS. And then the design is prepared in GIS-based system that creates the bill of materials. So you've got GIS at two critical junctures of here, one at the time of planning, then at the time of designing. The costing based on the bill of material as generated from GIS is done in the ERP system. Then the field work is done. Now, at the time of field work, there are deviations at times witnessed from the original plan. So all that our project members have to do is to sketch out the deviations, which we call as redlining. Based on this input, the as-built data update is done in the GIS system, which then goes at one end to the operation system, which is the ADMS, and at the other end, it is reconciled with the financial asset register of the organization. And then a scheme is technically completed. So these are this takes care of all new works that are done on field are updated in the system, so that the system remains live. And this year, so another thing is that we should keep on rediscovering ourselves. And each GIS day, we have started this from last year, we try to do something or the other. So this year on World GIS Day, we implemented what we call as TAPOPAN, or Tata Power Delhi Positional Accuracy Network, wherein we implemented a continuously operating reference station so that we can have the required coordinate accuracy, because the existing GPS, onboard GPS of mobile devices, they have got an inherent inaccuracy of 4.9 meters here and there. So now that, needless to say, that DGNS-based real-time kinematic-based system brings it down to even centimeter millimeter level. And if you see, so this is the corners of a fenced transformer that we captured using a DGPS system. And these were the coordinates that were captured using standard mobile. And in days to come, we wish to scale it up further, and most importantly, use it for underground cable location, joint location, because that is where the most of the challenges lie for us as well as our stakeholders from other utilities. So in case we are able to provide accurate data, so that can be of benefit to us, to our other utilities, and to the consumers at large. And definitely, so with the data available in GIS, it becomes possible to exchange those location related to consumers, to transformers, to circuits, and generate very good analytical reports from a platform like a big data or a HANA platform. So this is something that we've been doing. Now, in a way, GIS is also acting as a bridge between IT and OT. So at the IT side of it, you've got ERP, you've got GIS. Till such time, it was not fueling the OT side. And then the other hand side, you've got OMS, DMS, SCADA, which is the OT side. Now, there are some hurdles that exist to bridge this gap. One is non-automated process flows, no referential data, and the employee indifference. Technology providers can help to an extent. So they can give you a very good technology. But to utilize those technology, you need a lot of deliberation to be done at the utility side. So the stake of the utility cannot be ruled out, and the role that it has to play. And what are those? You have to put specific consistency checks that is required to be ensured to have a operations capable GIS data. You need to have automated business process integration. You need to have process interlocks. And I'm glad that the training part was taken up already. So training also is very important. And all this actually provide that strong change. It has to be driven using a strong change management foundation. So then you
Mr.
can actually...
Mr. Banerjee,
Yes.
I would like to remind you, you would have about a minute to complete your presentation.
Sure. But then there is a caution that we have to apply, and that is, what if the GIS data goes wrong? If it goes wrong, it becomes a mutant, and it starts behaving in its own manner. You've got wrong prediction, you've got asset mismatch, you've got energy audit variances. So how do you ensure that your GIS data doesn't go wrong? So this is a crux of our learnings, that there is an initial investment on infra that you have to put in, on the hardware, software, and content. So when I say content, I mean third-party data, satellite imagery. You have to invest on training. You have to invest on sustenance. A dedicated core team of GIS does help. You have to invest on new technologies, and most importantly, you must have measurement and control on whatever you do. You should define KPIs and quality indices so that you can gauge. And this is what we have been doing. We have defined our own KPI to ensure that the data gets counted and accounted. We call it the 3 C's of data, which is covering coverage, conformance, and the cycle time, using which we ensure that all new work execution, new connection, operational changes get verified as part of our process checklist, and it gets synchronized to the operation system. And to monitor all these, you've got a measurement and control in the forms of KPIs and daily work management principles. Now, the 4th C of convenience. So this is where I'm going to end my presentation with. So this is where we would like our technology partners to come up with, to, apart from the 3 C's, the 4th C of convenience, because GIS is almost always input is provided by a stakeholder who is working on field. They are the best people to provide you with that insight. So there is a definite innovation in mobility that is required, using probably things like computer vision, artificial intelligence, deep learning, geo AI as it is termed now, using LiDAR, because now iPhone is coming with LiDAR on their mobile device. So why not use it and see whether we can do something about it using point clouds. and probably we can the system itself can find out, looking at the field itself using the camera, which can be built on a smart glass camera, that it can tell that the network on field is deviant from the network that you have in the GIS system. So correlation, comparison using on-field technologies, sensors on field or sensing from field, is the new mantra that can probably help us in ensuring a high accurate GIS data. So with that, I'll come to the end of my presentation. Thank you.
Thank you very much, Mr. Banerjee. It was a very nice presentation, completely covering the ADMS, including SCADA, DMS, and your OMS. And also, we would like to congratulate you could achieve a 7.88 loss, which is really, really phenomenal comparing to any other DISCOM that we have probably in India. And you are able to, use the geospatial technologies. I think starting from, the consumer and OMS till your SCADA. I do not see really any questions on the Q&A box, but I would like to ask you, what are the key things when somebody is going to implement a GIS project or a GIS system? What are the things that they have to take into consideration? Because I would also relate this to the time when you have taken over from the erstwhile DESU, probably when you have taken over, probably the systems were not there, and the network was not known to you where the lines were going. And how did you actually manage to bring the entire data onto a GIS platform and come to this level of bringing it down to 7.88%, which is a phenomenal achievement?
Thanks for the question. So initially, there is a hard work that doesn't go anywhere. So there is a lot of hard work, reconciliation to be done, and coordination to be done. So the mool mantra will be to have a buy-in from the stakeholders. So people who are working on field, so you need to have a buy-in from them, and then they should be able to trust. So once you have started developing the GIS system, there should be a factor by which you can bring in the trust of the stakeholder that this system is going to help me and it is not going to be a overhead for me. You need to have data that can be trusted, and the data has to be showcased in time, because data delayed is actually data denied. And then there has to be a feedback mechanism, and there has to be a monitoring and control. I think the most important part is to have a monitoring and control mechanism wherein you can give positive feedback to the stakeholder about data which can be populated with the collaboration with your stakeholders.
Yes, I think buy-in internally as well as externally is something which is very, very important, and I really appreciate your presentation. It was a very detailed presentation, and we can see that you are using geospatial technologies in probably every sense of the word, and you have even mentioned CORS, that is continuously operated reference stations, and reducing or increasing your accuracies for mapping your elements on the ground. So thank you very much. And Megha, I would like you to request to the next speaker.
Yeah, we have one question which just came from Vladimir. He's saying, what data, LiDAR or satellite imagery, are you preferring at Tata Power?
See, I think it has to be a combination of both. In the sense, the kind of algorithms that are being developed, it makes the best of the both worlds. So because with the satellite imagery, you can do some image recognition algorithms. Along with that, the LiDAR data. So I think the best combination will be that they work together and gives us insight. So typically on vegetation management is one aspect that we are looking into. And that is one area of improvement that we see, wherein we see machine learning playing its role, and probably using much more accurate satellite imagery, because the typical satellite imageries are 16 centimeter resolution. There are solutions available which are 15 centimeter also. I can understand that Maxar has got very good satellite imageries, but then using that with AI, what kind of insights that can be thought of is an area that we'll liking to explore.
Great.
For
Thank you so much.
vegetation management, sorry, just to add in vegetation management, probably LiDAR data could be a much better data that you could use as well.
Yes, definitely, definitely. And as a matter of fact, I don't see I do see a time coming in the future wherein LiDAR, instead of having being mounted on drones, you might have it on your, so it's iPhone already has it. We need to just find out use cases, and probably the other thing that at times I see in the journals is that there are Indians working in foreign territories and doing magic. Probably we need to bring in those kind of innovations because we have the capabilities, we have the technologies. So these engagement and platforms like this in particular probably bridges the gap between the industry, the technology providers, and this can probably create that excitement that is required to do new things. And let's do it from India itself. Why do we have to ape things from the Western world when we know that it is there are a bulk of Indian people who are working out there and probably bringing those innovations. So that's my patriotic summary to close this session today.
True. True.
Thank you so much, Dhruba.
Thank you.
Thank you for your insights and your very detailed presentation. We are moving on to the next speaker, which is Mr. AP Singh. He is the Chief Engineer Computerization from Uttar Pradesh Power Corporation Limited. Mr. Singh has over 3 decades of experience in electric utilities sector. Currently, he's a chief engineer, as I said, he's a chief engineer computerization at UPPCL, and he holds a Master of Technology from BITS Pillai and an executive MBA from IIM Ahmedabad. He's giving a presentation on GIS deployment at UPPCL and its integration with other systems.
Thank you, Megha. Can you load my presentation or should I do it myself?
Sir, we will load the presentation for you.
Please,
Just give us
thank you.
a second.
Yeah, there is a bit of correction in the introduction. I am superintending engineer, not the chief engineer, as said by Megha. So there is a minor correction. So yes, moving forward.
We've loaded your presentation, sir. You can start and let me know when you want me to change the slide.
Right. So good afternoon, everyone. Thank you for the introduction, Megha. And after a very informative presentation by Mr. Banerjee, nothing much is left to explain. But I come from the largest utility in India, which has over 30 million consumers spread across 232,000 square kilometer area of a state, and which include over 1 lakh villages. So I'll put up the perspective of a utility, which is government utility in this webinar. So after having the very exhaustive and technologically advanced implementation in Tata Power, I'll also put up how the utility like UP takes the advanced technology like geospatial technology in electric utilities. So next slide, please. So slight history. Geospatial technology has come a long way from earlier. The geospatial part was done by the simple CAD. Now, as we have discussed, they come with drone and LiDAR and radar and many other things. So, but the primary goal in an electric utility is to plan and manage the facilities to deliver the electricities. So this is the primary goal, and geospatial technologies help utilities to digitize the electrical network. But even without that, utilities have been doing this. So what is extra that geospatial technologies bring in on the table, and how really the utilities can benefit from these technologies? So like this, digitization of complete network planning, digitalization of everything is in vogue, and primarily digitization of network assets or assets of any facility utility is a basically essential thing, unavoidable thing today. So the basic problem in India, as we see, is the planning, network planning. It is mostly random in nature, and I would say depend upon the funds and the grants from the lending agencies. So whenever it comes to the planning side, generally what in utilities people do, they start doing from anywhere and lead to anywhere. So that is the kind of network planning that happens as of now. But with the geospatial technologies in place, we can hope that it would be much structured and have some systematic working. So other thing is energy audit. Energy losses have been for the long time have been the pain area, and many approaches have been tried, but and of course there has been reduction in losses, but still much is to be done. So without GIS application in place, the actual assessment of technical as well as the non-technical losses is difficult. So energy auditing actually can be done with the help of geospatial technologies, and thereby the calculation of technical losses and then reducing the non-technical losses. Now, all the utilities in India are basically governed by the regulations, and there are regulatory commissions which give them cost plus tariff. So, utilities have to submit ARR annually and to get the tariff. So, basically the depreciation of assets is a major component in the ARR. So unless we add the actual picture of the assets to the applications which calculate the asset value, or which they submit the reports as per the desired format to the regulatory commissions, like geospatial technologies, it's difficult to get to convince the regulator about the asset value, and thereby the cost of depreciation that is taken into the tariff. And so now when we have this picture, there are many other things like decision making from time to time. It helps to reduce costs, customize workflows. So things become more systematic. This is how the role of geospatial technologies is envisaged in electric utilities, and I have touched upon the state of affair in Indian context, in government utilities in Indian context. Next slide, please. So when we talk to the people inside the utility and discuss about the usage of this technology, so some consider this is a very fancy technology. Others find it very complex and difficult to use. This is a hard fact. This is how the people perceive. Even those who can use, they also find difficult to maintain. And generally, utilities in India see little value addition in digitizing geo assets as of now through geospatial technologies. And that's why, because we begin with RAP DRP program, there were only in UP there were 168 towns, and we completed GIS mapping of assets, and after that we also completed the GIS asset mapping in IPDS towns. But the hard fact is people are not very keen to use, or even not even willing to use that kind of technology because of the limitation we will discuss in due course of this presentation. So we had limited success in deployment and very poor kind of change management, not in UP and elsewhere also. So but data, if data is still in GIS, then that is a big problem. So that is how the current state of geospatial technologies in India is. Next slide, please. Though Mr. Banerjee has touched upon, but for the sake of completeness, when we see the interlinkages with other functional areas of utility. So geospatial technologies or GIS, asset mapping of GIS and consumers, plays very important role in every aspect of the functioning of utility. It be it the network analysis, engineering design, customer service, general management, and in terms of utilities that are investor owned, it is the marketing efforts and operations, of course. So when the databases of these functional areas are integrated with the geospatial databases, so they enhance value. So that's how is the relationship. We know all, but for the sake of completeness of this presentation. Next slide, please. So I'll briefly give a view of how we have done this in UP. Earlier in 168 towns, we did asset mapping and consumer indexing in REP, DRP towns. They were 168 across all 4 discoms. Now there are 433 towns and IPDS. So in all, over 600 towns, we have completed a GIS asset mapping work, and we are also going for change management in RAP DRP town, because data for a long time has not been edited, and there has been a lot of network expansion, network changes. So that is also being taken up now. So we have taken a fresh approach towards the GIS, and we have really updated our IT systems. We have put up the latest version of the application software from ISRI, and also refreshed our databases. So all kind of new IT systems we have put up for these things, which are there, and the technical audit, GIS based outage management, SCADA implementation is also on the way, and we are implementing RTDAS. So all these things, for to have a proper match with these things, we have gone for a technology refresh, and this is the extent of our work in over 600 towns, where we have completed the GIS survey, and we have also ported the data onto the GIS platform, which is interconnected with the identity and access management system of our IT system. So next slide, please. So this is how we convince our users to start working with the GIS application, because generally, when they can do away with this kind of thing, they will do away with this. They won't use this. So what we try to convince them, that at least you have a brief state of your assets inside your, within your jurisdictional area. How many feeders, how many substations, and how many consumers, or this is the first kind of report we try to put up to our users, who are the very basic users. Then when they start seeing value in it, when they need some kind of report, they have a report with them, so they start using this software. So then we see how you can have more from this. Next slide, please. So this is the brief summary that will be immediately available to the user, a town summary. He can have immediately. So when he is preparing estimate for something, so he has this this kind of brief, this thing for preparing DPR, or want to add simple needs some kind of polls. For example, for operation and maintenance, he wants to prepare certain estimate for annual estimate. So then he has a brief summary. So then what the importance of this is that he has the information from the real database. So once he has this first-hand summary, then perhaps he intends to update the data also. Then he puts he would like to have the the significance of this and the system in his mind, and use it properly. So that is the first and foremost thing that we have learned from our APDRP area. We have had a very good system. We have prepared a very hard work on the preparing the base maps and the whole asset networking. But the system was not effectively used. So we are starting with giving simple reports, MIS reports to the ground level users like junior engineers or subdivisional officers kind of thing. Next slide, please. So we added something into this. Suppose DTs, when we recently surveyed the assets, we also, had the pictures of the DTs. So suppose a person is transferred and is not knowing about the site properly, and this picture simply would give him, when he clicks on the GIS attributes, the picture is also embedded in it. He sees that at least at the first hand, he can know the state of affair at the site, whether it is good or it is bad, or something is to be done, or what can be done. So people get transferred from one place to another. So knowledge is generally not transferred to the people. So with this kind of information available on the system, one can have very handy information, and then he can make his own plans and how to proceed, what is to be done in the field. But ultimately, junior engineers and subdivisional officers are the ground level, executives who do all kind of things, and they should be given this information, and then only it would be used. So next slide, please. Now, what we have, thought of, we are also implementing ERP, SAP S/4HANA. So from the very beginning, and simultaneously, we are also completing this. We have just completed this asset mapping to use it immediately with the ERP systems. So we have, as I have shown in the earlier slide, we have summary kind of thing, and then we are adding cost information and the information regarding the time of installation and commissioning of the assets. So with this kind of information added and pushed to the ERP systems, then it gives the asset register, the fixed asset register kind of thing, which is required for the submission of ARR and other budget, balance sheets and other places. So this is the effort to enhance the utilization of the GIS and to use it immediately with the ERP systems that is in place. So next slide, please. And this is another view of how we are using it in our GIS in ERP system. So what we have done, we have integrated the GIS system with the ERP system. So as soon as we create asset, we push it to the ERP system. So next slide, please. So I'll quickly touch upon the issues, concern, and challenges I have discussed in this presentation, but to have the emphasis again. So actually, what we have floated tenders for GIS asset mapping and the system integration. We found that there is still limited availability of service providers, and the ecosystem is not as strong as it should be, considering the scope and potential in India, particularly with utilities. So, the ecosystem of GIS service provider should be more strong, and perhaps then they will be pushing more, and there will be competitive work. So that is one thing. And the other thing, as discussed earlier, the quality of field survey is also perhaps lacking, and we need more efforts in technology in the field survey. And perhaps now it is better. Earlier, 8 years back and 10 years, it was not that kind of thing. Now we have cross checks on the field survey, but quality of data which we get on the GIS platform is directly related with the quality of field survey, and thereby the reliability becomes an issue if the field survey is not that good.
Mr. Singh, sorry to interrupt you, but I think we will have to complete this in next 2 minutes, please.
Yes, I'll do that. This is the second last. And there is one more thing which we see. After the survey and then making the data available on the system, there is a high cycle time. It takes around 1 month or more than 1 month here in UP, in our place. So that is one obstacle we need to overcome. And sizing of the IT systems is perhaps, as I said, the service providers, I mean, they're short of figuring out what type, how much should be the sizing of the IT systems, which give a user a very good experience, usage experience. So generally, I mean, it takes time to load the pages, and then users become, I mean, they are not very sound feeling in that. So that is the thing. These are the concern. And next slide, please. Simultaneously, when there are opportunities, as earlier speaker said, and now there are many things which will require geolocation services like rooftop solar. There will be prosumers which must know where are they located, and customer surveys. As we see, there is requirement of route optimization, of the crew management, all these things which I mean have bearing on the cost of the utility and the efficiency of operations, definitely be helped by the geospatial technologies. So there are opportunities, and we will move forward with this, and simultaneously we will also cut the losses, energy losses, and through energy accounting. So all these things will help utilities, which in turn will make the GIS application more widespread. So that is next slide, last slide. So that's all from my side. And any questions, please?
So, Mr. Singh, I really appreciate your very frank presentation on how UP has implemented geospatial solutions in various projects like APDRP and IPDS. And as you mentioned, it is a very large area, which is probably bigger than some other countries around us. What we see, Uttar Pradesh is a large area, and you have talked about implementing this in about 600 plus towns, RAPD, PRP towns, as well as IPDS towns. Some of the things that you have said, implementation of the geospatial technologies, there are certain limitations in terms of the quality of surveys that are being done, and also the limited availability of service providers. This is something which has been, an opportunity for the geospatial service providers, and there are a lot of new technologies that have come up, which can give you complete solutions. But sir, my question is, do you really also think that there is a requirement for internal understanding and acceptance of this kind of a technologies in various DISCOM offices, as well as the people at the lower levels? They have to implement these solutions, and there is a real requirement for training the people across UPCL on IT as well as GIS solutions.
Yeah, exactly. You have touched the right thing, and I have really discussed only this thing in my presentation. Training and basically the interest of the people on the ground level. I mean, as I said in my presentation, a small single report that helps a user at the end user. So that creates some interest, and then he will tend to have the training part of it, or then more knowledge impartment can be done. So first thing is the people understand the direct value to them at the ground level. So that's the thing I have tried to elaborate in this presentation. So you're very right. I mean, training and knowledge sharing is the important thing. But as I said, the ecosystem or the training partners are still, yet to be built up properly. So that is the area where we all need to work.
Sure. I would be checking if there are any further questions from the audience. I don't seem to have any questions. And also, I would just like to add to what you said about the people getting transferred. If somebody is actually doing a project and all of a sudden industry he gets transferred, the knowledge transfer is very important, because as an industry, when we are doing a project with an organization, and the main person who is actually championing this project gets transferred, then there is really a lacuna which develops, and the project has to be either starts all over again, or it doesn't get that continuity that is required. So I think something needs to be done as per that particular point also. So Thank you very much, sir, for a very detailed presentation and showing us a lot of opportunities where the geospatial industry can be, of use for implementing geospatial technologies in UPPCL. I think as an industry organization, AGI, Association of Geospatial Industries, would like to be in touch with you to understand and also give you a complete details about who are the good service providers who can give you quality data, quality implementation of geospatial services. That's what AGI aspires to do, and definitely we will be in touch with you to take your projects forward. Thank you very much.
Thank you.
Thank you, Mr. Singh. We now have two industry presentations by our sponsors, Maxa Technologies and ESRI India. I would like to invite Sherley Shankar, who is the Manager, Sales Engineering Asia Pacific from Maxa Technologies, to give his presentation. Shailesh has been active in the field of remote sensing and GIS for the past 18 years. He has a master's degree in environmental science. He has served various roles in the industry, managing pre-sales, business development, and project implementation with prominent companies in the industry. Over the years, he has gained a wide experience in various industry domains. So, over to you, Shailesh.
Yeah, thank you, Megha. And what I intend to do in this session, Megha, can you see my screen? I hope it's visible.
Yes, your screen is visible and we can see and hear you well.
Thank you so much. So what I intend to do is cover two aspects, and primarily I'm going to take this from a space technology standpoint. And after all the deep insights that we've got from the previous presenters, especially from all that we have heard in terms of the actual practical issues, practical challenges, as well as the benefits and advantages of having this technology, I would try to elaborate from a transmission as well as from a distribution standpoint exactly what space technologies has to offer as far as the overall technology stack is concerned. So if you look primarily from from the overall gamut, from from the generation to the distribution, from the start point to the end point, if you look, space technologies has a component to play in each of these. Whether it's the generation of whether it's mining, extracting of all the raw material, to the actual creation of the plant, to the transmission as well as to the distribution. But for this presentation, we will primarily focus on the transmission and the distribution stage only. Now, moving ahead, one thing which I would like to primarily emphasize before I start the presentation is that when you look at satellite image, whenever you start your project and whenever you're deciding that, okay, I need to do a utility-based GIS, the first thing that comes to your mind is that you need a map. You need a map which is accurate, which will stay with you, and that is foundational, right? And that's why I say that your satellite image which you use is the base of the entire data set that you generate. So when you think of a GIS platform, then and you look at the different technologies that you want to. So if you take RAPDRP, for example, you have GIS, which becomes a hub, and you have the energy audit, you have the SCADA, you have the CRM, everything plugging in and giving the input, and GIS becomes kind of the as Jack Dunstable says, as the living living twin of what your network is outside as well as what is on the system. Now, similarly, when you look at the GIS system in a nutshell, the base of the GIS system itself is your satellite imagery, because your primary land-based map is coming from the satellite data. So I would like to emphasize, and going forward, I'll give you certain examples of how I try to cut corners here. I'm going to be very candid about it, where we try to cut corners and we end up in a lot of trouble. But your satellite image is the base on which you actually extract a lot of information layers. Then you also overlay your network, and then you have your other inputs coming in, and that forms your entire GIS system. Now, if you look at the planning system, as I was mentioning, you start with a satellite image, and on the satellite image, you want to plot all the towers. This would mean that even in a distribution system, you're trying to plot all your assets. You actually define your corridors, and from there, you want to actually define within the corridor which is the best route or which is the optimal route. Now, covering the transmission segment, what happens for most of the companies who are building transmission lines, there was always an impediment because they would have to estimate their routes. They would have to do all the estimates without the core data. I mean, there were issues from the way the data was being disseminated versus what data was available. Today, whether you're looking at transmission or whether you're looking at distribution, there is elevation data which is available at 50 centimeters resolution. So that means 50 centimeter posting, you have data for across the globe. It can be generated very, very quickly with a 3 meters SE90 accuracy. So this is something which you do not need stereoscopy or you don't need those traditional technologies to develop. It can be developed very quickly. So for a rapid planning or for a quick bid estimate, you have that kind of elevation data, which is available quick to use. You use the data to do your optimal route analysis. You can add your different layers and do, what is the best route planning you should take. And based on basis that you can do your planning. Now, as I said, I promised you I'll be very candid. One of the shortcuts we generally tend to use is use Google Earth. Well, a lot of Maxar imagery is on Google Earth, and I would definitely say wherever it saves you cost, you should. Wherever you can use this free sources of data, you absolutely should. Sentinel, Landsat are great sources of data, but then when it comes to engineering level activities, which we do, there is a lot of difference. So here is an example of what we are doing. So let me just quickly pull up my laser pointer. Now, this is a very high resolution 50 centimeter elevation data, whereas to your left, what you're looking at is the Google Earth. Now, if you see the profile along this hill which I've taken, you can clearly see this profile, and you see the same profile out here. Now, if you look at certain locations, so for example, this particular portion, all these kinks, bends, these hills and valleys which you're looking at here, if you look at the same thing on the Google Earth, everything is absolutely missing. So when you are doing your profile, when you're doing your analysis, you can imagine the kind of details that you're missing on ground. Furthermore, when you're doing measurements, you can see the difference in the measurements. I mean, these are not numbers which you can take lightly, because going forward, these are the kind of differences which will impact your overall map and the overall content that actually you create. And the challenge is, once you've created a base map, once you've created the content, once you've planned it, the amount of impact that it has to go back and change your design. So I would definitely encourage a level of conversation where we discuss that when you're planning a new transmission route, and you do the planning or very initial planning on Google Earth, and when you go on ground and you do the LiDAR survey, the difference that you actually find between actually what you have planned versus what you get is the cost worth putting in certain amount of data. We can do that cost benefit analysis there and then. Now, moving out to the operation and maintenance of either transmission or distribution networks. This is, for example, the same transmission line which I showed you earlier. If you take one particular location out here and zoom to it, you will see the transmission towers. You will also see a lot of vegetation. Now, this is applicable to distribution networks as well. You have to try and keep your network free and away from any kind of vegetation that's happening, right? Now, also, you have to keep monitoring so that once the interventions which you're taking, those interventions are visible, those interventions are effective. Many a times you are putting this, you're giving this as a contract. So your bills of material actually get defined from here in terms of how much has to be cleared, what has to be cleared, the quantification. So there is a financial cost implication to this. So obviously, your system and base map need to be accurate so that what you pick out and what you give to the contractor is a clear estimate. Now, similarly, you also want to keep a view on your network assets, because there is always a chance that there is encroachments happening through your asset, through your network right of way. Also, there are changes happening. For example, land clearing or some kind of activities happening. You want to pick this up very, very early. If there is fires, there are floods, especially in places like Bombay, there are regular floods happening, and you have to react to those, right? So you want to know which areas are flooded. If any of your assets are damaged, there are any problems, then these things have to be kind of picked up and mapped. This is an example of how the vegetation is being monitored time over time. So it is not that you just have one base map and it's done. You need, your network assets are yours, but there are a lot of other factors which are actually impacting these network assets. So whether it's the vegetation around, whether it can be a climate and weather, it can be the atmosphere around, there can be people working on it. Someone might, even a simple truck can actually go and trip your wire down. So these kind of things have to be kept in mind. So you need to know if there are roads and what activities are happening around. So it's a constant kind of effort which you have to keep in picture. Now there's an example where we used a more intelligent system. So satellite imagery is an input. From the satellite image, the system will actually pick up a pre and post and understand actual how much vegetation is actually coming, how much vegetation is under the line, how much vegetation is coming close to the line, how much vegetation needs to be cleared. So this on a periodic basis can be actually measured, and this is being done in a mixed manner. A lot of training and intelligence is being built into the system. So the system can identify different kinds of trees, and from there it also estimates how tall those vegetation will be, and then based upon it can give advisories of how much needs to be cleared and so on and so forth. This is an example of the vegetation encroachment risk assessment. So the system can actually assess exactly which are the trees that needs to be chopped off or needs to be trimmed down. Similarly, for example, again, you can actually see how much of the area actually needs to be trimmed down, and these are actually the tower locations, and these are polygons covering the tree canopies. Now, out of this, considering the future, so we're considering the current height of the trees, considering the future, how much more the tree can actually grow, so and at what period. So you could do a futuristic prediction as well, that is the type of vegetation. So now going forward, I will have to do this kind of curation. And this is again because of the rapid elevation generation technology that we can do. So over time, we can keep generating these kind of models in a periodic basis. So for example, in this graph, you can actually see the vegetation height versus the height of your span line as well. Now coming specifically to distribution operators, right? So which is most of the crowd here. Again, emphasizing that you're foundationally, when you look at imagery, it creates your base map. So that is something which needs to be assessed very importantly. There's an image over Surat. So this is a 30 centimeter resolution imagery. So I could see that some of the users had mentioned about resolution, but I really wanted to show you what resolution actually means. Now, in a country like India, where flying an aeroplane, doing aerial photography is pretty challenging, you really don't have to do it, because the imagery quality from a satellite image has become so pronounced that you could actually see cars on the road. You could see each and every building. And even if you're looking at a very difficult kind of scenario, so for example, the Chandni Chowk in Delhi, or you're looking at some of the most congested places in Mumbai, you can have very good quality data where you can demarcate the building footprints, or you can demarcate streets, and your land-based map can be delineated very, very accurately and to a great amount of detail. Now, what's more is, while you have 30 centimeter data, we have been able to enhance this data as well. So we can take 50 centimeter data and convert it into what we call as 30 centimeter HD imagery. Similarly, what we can do is take 30 centimeter data and convert it into 15 centimeter high definition imagery. So this right now, what you're looking at is an example of a 15 centimeter high definition imagery. We are not saying that the sensor is 15 centimeter. The sensor is actually 30 centimeter. But what we essentially do is use a machine vision technology to identify different objects and actually enhance the entire image in such a way that the pixel size very intelligently becomes 15 centimeter, and the quality of imagery becomes much more crisper. The amount of data which you can see in a standard 30 centimeter imagery versus what you would be able to see in a 15 centimeter HD would be much larger. So we are enhancing the features and bringing out whatever the sensor is capturing. Right now, what are the advantages? Now, the advantages basically means that you could map much more accurately than they were doing before. Of course, it was sufficient. So within your existing data sets, you could now enrich it with periodic 30 centimeter or 15 centimeter HD, and then start capturing much more details than what you were doing before. Also, obviously, there would be a request. I have seen, and this is something which has been echoing to me for quite some time, and there has been a request, there have been requests, especially from the REP fraternity, that all the projects that you have done now obviously require a refresh. We have discussed about refresh and the issue of the data, of network data going stale, but we never, discussed the issue of the maps itself going stale. So I remember during the implementation of RAP-DRP typically happened between the 2010 to 2015 kind of scenario. If you consider even the last implementation, it's around 4 to 5 years which have gone through, and 4 to 5 years, most of the towns and cities have gone through such a large transformation. Now we will update the network, but then there is no building actually on the ground because we never plotted it. The maps are as old as they were at that time. So what we also need to do is update those maps. So there are two options to do this. One is that we have the highest resolution data or the high resolution data, which we procure fresh and we create the entire thing. We can do the entire mosaicing and delivering of the entire imagery mosaics. So traditionally what was doing is we were delivering that to the service providers. Even now that model is available, but if you want us to do it, that's something which we can do and deliver the entire state level mosaic, or for a specific discom we can actually create the mosaic and deliver it to you, so that is ready to use. You can just plug and play within your with your existing land base, and you can start updating the data. Now, many places, I would even go to the extent, my GIS friends may not be happy, but I would say that you may not really need to even digitize each and every building footprint. You might not need to even go into that investment. If you have the satellite imagery backdrop and you know the endpoint, even if you put a point to represent the meter, I think that's sufficient. In most of the scenarios today, what you're doing is you're putting a bulk metering system. So you will basically come to the not to the endpoint, to the end customer, but your end customer is one step before, where you are, for example, for an entire colony, you're providing one bulk metering. So you come to that particular transformer, and from there, the internal distribution is done by that particular colony or that particular residential complex. So in that case, you can see the entire residential complex. You can just come to the up till the transformer, and that's or the bulk distribution system, and that's it. So the advantage of keeping this refreshed is quite pretty big. What we can also do is have it as a subscription service. So this can be a plugin within your existing GIS. What was stopping this earlier, the technology was always there. We have moved our entire data onto the AWS cloud. So whatever we are collecting on a daily basis, we are actually transmitting it out to the entire globe. The only limiting factor was the remote sensing data policy. The draft is out. Hopefully things will actually improve, and then we will be able to provide the subscriptions to you directly, and you would be able to plug and play this system straight within your existing platforms. Finally, again, coming back to using free data versus using reliable data, I created certain examples. So for example, here you see a network which is placed along with Bing Maps. So this is again free, but you will see that when you overlay another layer of data, which I picked from Maxa, you can actually see the shift. So efficient, and there's an enormous shift between the two maps. This kind of shift, and when the base is actually shifting, that's when your entire network suddenly starts getting scattered. Let me give you another example, and this is more interesting. So I took Google Maps itself. So this is an image of Google Earth which you're looking. If you look at this particular location, right, the network says that this is the termination point, which feels funny because it cannot be here. But nevertheless, I'm not questioning the network at all. But if you look, let us assume that this is the point where things have terminated, or even this point, this is the last point. I have just changed the map, the Google map itself. So in time, what Google Maps image was in 2017 versus what it was in 2019. So as soon as your map or your satellite image changes, everything is shifting. Now, what would you say? Is this correct or is this correct? So I have seen many of my friends and colleagues face this same situation in many of their utilities, where they have used these free data sources. So while I would totally encourage wherever you can, definitely save cost and use this, but then my only humble request is that this should not cause a detrimental impact, or you should not reach a scenario where you have built an entire network and then you can't roll back. That becomes a very, very difficult scenario. That's the primary reason why I put this slide in. So your maps and your satellite image are foundational. So these foundational image are extremely critical for your overall network to be sustained in a very, very accurate manner. I loved when Mr. Banerjee from Tata Power mentioned the use of coarse network. Now, when you use coarse network, you have such high precision that your maps, underlying maps, also have to be of such high precision. So both of them need to be mapped. Just very quickly, moving on to renewables. We also have a service as far as the renewables is concerned. So what we can do is, there are two types of solutions which are coming into the market. One is from a weather perspective, where you can estimate the amount of solar generation or wind power generation that can be done. So basis that, the amount of power that's going to come into the grid from the solar or the wind, you could actually adjust your overall grid according to that. So there are models available in terms, for example, tomorrow is going to be very bright and sunny. So we could tell you in advance that, hey, tomorrow is going to be bright and sunny. This is the likely power generation that will happen. So based upon that, you could actually reduce the incoming from the coal-based or the gas-powered generation systems, so that you can adjust the two. Similarly, what we can also do is create 3D models which can tell you which are the areas of high solar potential. So if you want to harness rooftop solar potential, generate more power, which can actually feed your grid, then this is a classic example. We have earlier speakers speaking about the prosumers. This is a classic solution for where you want to harvest or leverage the prosumers. That overall, yes, I'm more or less there.
Okay, you are done. Okay.
I didn't give you a chance, did I?
No, you didn't. You're absolutely bang on. Sorry.
So if there are any questions, I can take that now.
Yeah, I have a couple of questions from the Q&A. One was asked way earlier when Sai has made a presentation. The question is from Vladimir, and it says, which Maxar products are integrated into GIS services for monitoring of power lines in India? And what are these services, commercial or government?
So Vladimir, I mentioned that, and I hope that I covered a lot of them in my presentation. Primarily, just to reiterate, satellite imagery at very, very high resolution. So, and I would like to club this with one other question which was asked to the previous speaker, to one of the previous speakers on LiDAR versus satellite imagery. I would definitely concur with the response that both are complementary technologies. LiDAR is extremely good. In fact, I would add one more dimension to this, is the drones or the optical drones, right? Optical drones can go up till good about 2, 3, 4 centimeter kind of resolution. So when you're doing a very fine-grained assessment of your assets, you are trying to do maintenance kind of requirement of your assets. There, a satellite cannot give you that fine-grained resolution, so it makes sense to go with a drone survey. Many a times, traditionally, what was an issue with satellite systems was that they couldn't give you very efficient three-dimensional mapping. So vegetation heights and those kind of things needed you to do stereoscopy, which to a great extent we have overcome. In fact, going forward, what we will be doing, our next constellation, which is launching early next year, we are having multiple satellites doing multiple revisits in a day and from different angles. So you have enough imagery to create what is called as a pseudo stereoscopy or a multi-ray technology, and you can create these 3D models very, very quickly, because of which you will be able to generate 3D models and understand vegetation heights. So in a nutshell, to answer specifically your question, it's satellite imagery, the base map to generate your base map, and to get information with regards to whether it's vegetation, land use patterns, any kind of encroachments. This is where Maxar provides its its services, plus elevation models and elevation data. We also do certain services around theft. We have efficiency. We have analysts who can do a probability assessment. So, for example, if Chhattisgarh State Electricity Board wants to assess what are the probable locations in South Chhattisgarh areas like the Bastar and those areas, which are the probable areas where they are likely to face conductor thefts, we can support with that as well. Sorry, Sri, back to you.
Yeah, thanks, Elish. And the other question is from Smita Rajanwar. Is Google Earth recommended to be used as an authentic reference?
When you say reference, if you want to just use for visual, see, Google Earth is been created from a perspective of giving you a view of the entire globe. You can go see any place. I will ask a simple question. Does Google ever commit on an accuracy? Right? You would never see that they would commit saying that, okay, this image which I've authenticated, I've placed is at a certain level of accuracy. Do they co-register their images when they refresh? Does every image align and set one over the other? And I would not, this is not a negative statement as for Google. The purpose of Google is something very different. So when you want to do a visual interpretation, you just want to see the location, you want to do a very quick assessment, please, by all means. But the minute you want to measure something, the minute you want to plan something on it, then is definitely, I would clearly say that it's not a recommended platform. It is just a visualization platform.
Okay, we have a couple of more questions from Lamir. One is, you can only enhance RGB images, as you have said, about 15 centimeter HD. And the other question is, product for vegetation mapping, is it Maxar's partner or a proprietary software?
So Vladimir, to your first question, we can enhance all the satellites. Right now, you have Worldview 2 and Worldview 3, which are 8-band sensors. Worldview 3 has additional shortwave infrared. The new constellation that we are launching, that is Worldview Legion, is all going to be 8-band sensors. So we can not only enhance RGB, we can actually enhance different different spectral bands as well. But when it comes specifically to creating HD imagery, we primarily focus on the RGB because that's where the algorithm is best trained on. But nevertheless, if you need the different spectrum, typically if you're doing spectral analysis, I would not recommend an HD. I would recommend the pure bands to be used. So if you're doing a vegetation analysis, you're trying to decipher between different types of trees, then I would prefer, I would recommend you to go for the pure 8 bands, which in case of 30 centimeter will be 1.24 meter, the spectral resolution images. Right? Coming to your specific question on vegetation, we can do vegetation mapping, but so we can pick up specific kind of vegetation. We can pick up height information as well. That is something which, as a part of the Radiant group, we have services through that. But if there are some things more specific, so for example, there are certain charts which I showed, which was doing year-on-year analysis, right? So that's where we can bring in our partners who specialize in the domain and give you specific insights on the network.
Okay, Shailesh, before we let you go, I have a question. I think when we use a 50 centimeter or 30 centimeter data, we are very clearly able to see the transmission towers, which are visible, and we can map them.
Right.
And the biggest problem in distribution network mapping is picking up the pole positions. And these poles, whenever you do, normally it is mandated that you do pole surveys with DGPS and actually bring in the data. In the last presentation, Mr. Singh also has said that the quality of survey, which of course is a big point that we have to touch upon. But my question is, using a 15 centimeter HD that you have talked about, can we actually look at the poles positions with a decent size of accuracy, even using ML or something like that? That would solve a huge problem, I believe.
That would. And there are a couple of scenarios in which it would. Now, poles typically are visible. So I'll be honest, 15 centimeter HD is something which we have released only recently. It's just part of the Aman, practically couple of weeks only, three to 4 weeks, where we have put it under general availability. So frankly, I have really not drilled down personally into seeing actually electric poles. But yes, akin to that, traffic poles is something, and the light poles is something which has been visible with 30 centimeter imagery. So I'm more than confident that as far as 15 centimeter HD is going to concerned, they're going to be much more clearly visible. My concern would be especially in very congested areas where you have multiple poles going across, crisscrossing each other. That is something which I will definitely take up and review it deeper. So, but yes, I see the problem, and I think there can be a solution there.
Yeah, sorry, not only the urban areas where there is a lot of crisscrossing and very dense areas, all rural areas, the power distribution, when it is happening through the poles, if you can map that directly from satellite imageries, I think it is going to be a huge relief for all these big projects. When we are talking about
I completely agree. I completely agree. Rural areas, I'm more confident that it'll be possible because you should be able to pick up the poles. You should be able to map it. Some areas where there are adjacent houses, etc., and things may not be clear, but then poles have a specific structure and they have a specific spacing in which they're plotted. So you could always interpolate between that. My only concern where I flagged it off was on the urban side, but yeah, I'm pretty confident on the rural side you should be able to do this.
But I think we should do some small POC and actually demonstrate. This would be very useful, actually.
Absolutely, that's what I was suggesting. So yes, I will take that up and we will do that as a concept.
Please, thanks, Sherley, for a very interesting presentation.
Thank you so much.
Yes, Mehta.
Thank you. And now I would like to invite the last speaker for the session, Dr. Pradeep N. He's the industry head, utilities and mining from ESRI India. Dr. Pradeep is currently, he has nearly 18 years of experience in the industry and research in the field of GIS technology application and consulting. Prior to joining ESRI India, he has worked with Rolta, supporting the Enterprise GIS Group. He began his GIS and remote sensing journey with Regional Remote Sensing Service Center of Indian Space Research as a research fellow, which culminated in his securing a PhD in the area of GIS and remote sensing application. So over to you, Pradeep. Pradeep, I think your mic is muted because we can see your presentation, but we can't hear you. Yes, I think now we'll be able to.
Thanks, Megha. Thank you so much. Thanks for the nice introduction. Hope it's visible.
Yes, your presentation is visible and we can hear you.
Okay. Thank you so much. And so far, all the esteemed speakers have talked about the role of geospatial technology in utilities and how they are being utilized, how it is being of value to them. But I'll come from a technology perspective, how the GIS in utilities itself is evolving. We have seen how earlier it was more from a mapping, it evolved into an enterprise GIS, and now what is required is an integrated, complete GIS kind of a thing. So how it is evolving, how the requirements from GIS and expectations from GIS is also changing as far as the utilities are concerned. To start with, I represent GSRI. We have the largest and the advanced GIS platform, locational analytics systems in the world, present across 80 countries and addressing and supporting a very large number of utility customers. And also in India, we've been here for more than 25, nearly 25 years now, and supporting very large amount of utility specific utility customers, both on power, gas, and oil and gas sectors. So to start with, when we look at GIS, it's becoming a fundamental language to understand and manage utilities, because how the network is, where they are, and it provides a context in terms of the various assets and its surroundings. So that is the basic fundamental language and meaning GIS brings to utilities while managing their network. So currently where we are looking at are how utilities are specifically utilizing is into map all their assets, publish them, have some integrations with the IT and the OT systems moving forward, and basically looking at an asset management perspective as well as their customer management systems. But this utility GIS is evolving. Now the requirement is that it needs to be technologically agnostic. It needs to be a device agnostic systems. We should be able to run it at the office, take it to the field, have it very light, and perform in a way in a high network area without an offline systems. And also the kind of requirement that is coming from a utility is also that earlier what static data was coming, now the requirement is to have real-time data integrations coming in. As the earlier speakers were looking at, we are also looking at some 3D information coming in. Earlier, what was the 2D maps having, but also at the same time, it should be able to integrate with third-party systems and also do a lot of analytics. So what we saw earlier, maybe during the APDRP time, which is the flagship when we are talking about an electric utility in India, of the transition from the analog systems to a digital systems coming in. But now we see that most of the utilities are looking at the digital transformation journey, where from the geospatial world, it's very exciting to see that organizations are looking as GIS as core to this particular transformation. So what applications were running to meet certain basic requirements of the utilities are now being changed or being run from a spatial context. So GIS becoming core and GIS driving this digital transformation is what enabling GIS to itself transform from an enterprise scale system to a complete GIS entity, wherein not only GIS as earlier needs to provide or manage and be in the single version of truth for all the asset, but it also needs to be capable to provide multiple applications and also enable analytics on top of it. While doing all this, the requirement from a transformation has been that customer, because now utilities are moving into an SLA based system, so customer experience, customer service is becoming important. The safety of those utility personnel is becoming very, very important. Adoption of best practices is sacrosanct, and also the grid modernization programs too. We have heard how the losses have been reduced, how the various interventions has led to better profitability of the utilities has increased. So all these are to be catered from a geospatial domain, leading to a lot of innovations, whether it's adoption of sensors, adoption of, or using of drone technology or LiDAR. So all these innovations are also being led, and that has internally put a requirement of a GIS being able to cater to these requirements, and hence a complete GIS requirement coming into the utility space, especially from a digital transformation scenario. So when we look at what this complete GIS look at, one is when we looked at earlier as the asset management systems, where we talked about mapping and designing. On the other end, we have the modernization, where we are bringing the grid edge mechanisms coming in, the smart grids coming onto it. But at the same time, the requirement of having an AI ML kind of a solution, having the 3D and AR kind of a requirements. But all this cannot be separate. It has to be an integrated. So a central core platform of GIS needs to provision the data according to these requirements. And hence, the utility GIS itself is now evolving to become a complete GIS mechanisms. And that's how what we are looking at from a ISRI perspective also, to evolve and meet these requirements so that we evolve into a complete GIS, enabling the utilities to have derive larger business values. So just to give an example, earlier planning, now the requirement is that the system should be intelligent enough to enable a very standards-based, parametric-based, or a modular system wherein we can model each of my outputs. So even before I get into the field, now we have very high precision satellite data coming in. We have the locational intelligence available. So if I can use these geospatial technologies and map my system even before I get into the field, that gives a very large amount of capability to the utilities. So into this, I can now bring in all my environmental impact requirements coming into it, all the alignment systems, the slope aspects parameters, and do initial estimations even before I send my team into the field. So this is where the intelligence into the GIS is coming in. Now, we have seen speakers before, Shailesh and all, talking about the use of the satellite data and how we can drape it and use a 3D visualization. Now, even once we map it, when we have a very high resolution data on top, we can ingest into the GIS platform and do a initial mapping and see whether the alignment is right, whether we can shift those alignments, how does it relate to the ground realities that has been captured, and also manage the vegetation. So we have seen this time and again, the speakers mentioning about vegetation management being primary importance, whether we integrate a LIDAR information from the cloud, point clouds, or we and drape it onto this, whether it's on the transmission lines, and how we can extend this into the distribution systems, whether as Mr. Dhruva said, that whether we can have a land-based LIDAR and utilize this. Yes, a GIS system is now expected to support these kind of a requirement, which will enable a better planning, better alignment, and also this would become input into the O&M mechanism. So traditionally, we have looked at the network mapping, and once we have the maps into the GIS system, how it can be used to look at the connectivity, the gaps, and all the systems. But another point that was very well articulated by the other speakers was, how do we bring in the field capabilities? How do we ensure that the field reality is on a near real time basis comes into it? So we have the entire suite of field applications today with the development of mobile technology. It's very easy to take the data onto the field and do the enhancements to reflect the ground realities. Once we do this, this is where it increases the operational intelligence. So the GIS system, from being a mapping system, it became into a decision support with the planning and all, with the intelligence data coming in. Now it is with the field data coming in, whether it's through a mobile device, whether it is through sensors, Now it is putting a lot of importance or increasing the operational intelligence of the utilities by integrating the field and the back office. We have talked about Mr. Pillai in the earlier in the session. He talked about the smart grids, its utility into the system. How so? Once we look at the smart grids and how GIS is a core into achieving the objectives of a smart grid. So this is an example wherein we can start monitoring the entire system on a near real-time basis, whether at the DT level or if you move further on, whether at the individual smart meter level that coming into it. So with a GIS system and an enterprise scale system, these kind of real-time integrations will definitely help to manage the entire network and enhance the role of geospatial technologies. The other important aspects coming in is with respect to the emergency management. Now we have capabilities to integrate the forecast. Shailesh also talked about in case of flooding or in case of a natural disasters. Now, if we have the weather forecast information available, now we are able to integrate all this into a single platform, and this is the requirement coming in, wherein data from very disparate data systems and third-party systems being able to exchange data and have it as a centralized mechanism wherein we are able to manage and monitor any emergency response requirement, also bring in a crew to address these requirements. Because of all this information, lot of data is being generated, lot of data is being captured, and that's where now GIS is also expected to be a system of analytical system, because all utilities are becoming very, very data rich. A simple way of looking at is we put in the entire system, whether at the state level or a county level, do analytics on top of the various components. Real-time monitoring, how the systems are performing, how a particular feeder is performing, whether it, so we can drill down or have a very summary information at a very high level. So simple analytics to a very complex analysis where we do an exploratory analysis. What if there is an outage over a period of time, if we capture and map what are the causes, whether there is a switch, there is a trip, whether the fuse blow out, what kind of issue on the network enabled this kind of an outage. So these kind of an exploratory analysis can be done on a spatial scale, and the requirement is towards this. Hence, when we look at it, GIS is now becoming cross-functional, wherein what started as an asset management now has moved into the operational awareness systems supported by the field operations, and also with the constant management, whether within the organization or within the customers. So this engagement is very, very essential, and that's where we talk about a complete GIS system. So to end, utilities are evolving. They are adopting all advanced technologies, and so is GIS is also evolving to support those systems and engage with those systems. Location is becoming very, very integral, and also this integration is the core as we move into the era of smart grids and smart utilities. So thank you so much. Thanks for your time. That's what.
Thank you, Dr. Pradeep, for an insightful presentation on ESRI technologies for various aspects of electrical utilities, starting from routing of the transmission lines and then asset management and field GIS. It's been a comprehensive presentation on the solution set that ESRI presents to the utilities. So I would like to see if you have any questions As of now, it looks like there are no questions. So with no questions from the audiences, I think we are coming to the closure of this particular sessions. In fact, I do not have any specific questions for you. Thank you very much for a nice presentation. Megha, I think we are good to go with Megha, are you available? So should we start off with my closing remarks?
Yes, please.
So thank you everyone for attending this webinar conducted by AGI for use of geospatial technologies and electrical utilities and the complete spectrum of operations that electrical utilities undertake. We have discussed today starting from generation, transmission and distribution. Of course, most of the discussions were centered about distribution because distribution is where there are a lot of ATC losses, and the efforts of the governments have been to control these losses. As been said in this presentation, the losses were almost to the tune of about 40 to 45% initially, and with the advent of these technologies, usage of geospatial technologies, there has been a lot of improvement, but still we have a long way to go, because even today the losses in the distribution level are at around 18 to 20% across many of the discoms. So depending upon how well the discom is driving this kind of an initiatives, then there has been a lot of advantage that they have derived. So we have also talked about smart grid. Smart grid initiatives, I think, are still to be really taken off in India, and one of the major important points about smart grid is all the elements starting from generation till the distribution to the consumer level, they're all developed and configured granularly, so that if there is any fault, and the fault is localized, so that the entire system is not tripped, and there is a two-way communication between every element to the other element. So these are things which are still a bit away, I think, for Indian systems to take over all these newer technologies and implement smart grid. They have taken a few pilot projects, but there is a huge scope for the geospatial industry to start getting into smart grid projects and provide solutions in this. I think we also talked about all the projects that government have launched, like APDRP, IPDS, so that everything focused on distribution systems and reducing the losses. Some of the few takeaways are, one is the user organizations. This, I think, probably we talk about every webinar. User organizations need to be trained, and the transfer of knowledge when people are transferred is very, very important. I think there is a lot of lack of awareness and knowledge, and the advantages that this technology can give for the people down the levels in discoms, and the kind of the working that discoms have, they don't even have the required IT infrastructure and IT capabilities. So I think that is some place which need to be filled. The kind of losses that we are looking at, even at around 18 to 20%, they are running into multi-billion dollars. The entire country is losing. Having said that, capacity building at discoms, etc., is something which definitely needs to be worked upon, and AGI is trying to do programs for even the institutions and discoms with Survey of India. I would like to see how well that program is going to come up. We are trying to make it happen. But lastly, I would like to definitely say that even the industry is responsible for the kind of situation or the kind of implementations that are happening. Like it has been mentioned, the quality of surveys are very bad. As the data that comes in is bad, so is going to be the outputs. And so I think we have to agree with this particular statement, that we do not have too many or good number of service providers and who are providing good quality data. I think it is undisputable fact, and mostly the surveys are being now replaced by technology, collecting the data and preparing the maps using things like ML and AI. I think that is a welcome move, but there is a lot of field surveys that are still required, and the companies, the service providers, have to really think about how well they can provide this data. So industry, I would say that the industry also has to be a little bit more responsible for providing the kind of solutions. And rather than just looking at grabbing business and becoming L1 in tenders, and after that looking at implementation with not so much seriousness. So I think these are the takeaways that we have for this, and it was a very enlightening webinar. A lot of people from different aspects, from industry as well as the users, government. So it has been wonderful, and I once again thank you very much, all of you from AGA's behalf. So thank you very much for attending this webinar, and we look forward again for our next webinar. Thank you.
Thank you so much, Sri. Thank you, done a great job. Thank you for supporting us. Thank you to all the attendees who've attended this webinar. I hope you found it useful. We will have the recording of the webinar available on our YouTube channel. We have been putting the link, and we will send it again with a thank you note to all of you. So see you next time.
Thank you.